Hey everyone, I am here with Mike Ness from the Amiga community, and we are here to do an AMOS-centric video. So what you see on the screen right now is the original proof of concept prototype for the game project DaemonClaw that Corey and I at BitBeamCannon are working on. The version we're working on now, and the first version that's going to be finished, is being made in Construct 2 and eventually Construct 3 for modern platforms. But we have a very skillful Amiga programmer lined up to make an actual Amiga port once this initial version is finished in Construct. Anyway, say hi to everyone, Mike.
Hello, everybody.
What we're going to cover in this video is going to be how we pulled off this back playfield looking layer here for the enhanced parallax scrolling. And this demo, I think it runs at a pretty solid 25 in PAL and 30 frames per second in NTSC
Right.
on even like an Amiga 500, you know, with all these nice layers of scrolling, and even when we have several of the basic flying giant bat enemies on screen. And I just wanted to explain what trick that we're using to get that back mountain range layer in there. All right, so let's break out of this and take a really quick look at the code. Let's search for, all right, so set Bob. Let's look for set Bob. Okay, so here it is. The trick is that back mountain layer is actually being drawn on top of the foreground graphics. So you've got a normal screen that's just being scrolled around by the usual methods in AMOS, but every frame we're re-stamping in, I guess using hardware coordinates, so to speak, so it's always in the same exact spot on the screen. It doesn't scroll with the rest. So we're basically updating and re-stamping down that back mountain range actually on top of the rest of the graphics, but we're using setBob to only draw specific bit planes of that image. And because of setBob and the fact that we're using very specific color indexes, it's creating the illusion that it's behind the rest of the graphics because it's only drawing into a specific color index.
Right.
But it's very tricky, which is why we're making this video, and there are very specific and fairly severe limitations that the artist and programmer need to work around in order to get this to work and to look correct. Because, well, let's actually quit this for now. We'll load back into it later and go into Brilliance. And we're going to load the actual, we'll start with the actual mountain range image that we blit every frame update to have that stay in place as the screen scrolls. There it is. So as you can see, it's the width of the entire screen width that we're using for the game, which I think to improve performance or maintain the best frame rate, you could see it's not a very tall image and it's not full 320 wide, I think. Let's see, what's the easiest way to check that in Brilliance? I guess right here. Yeah, it's 288. So we shrunk the screen width of the game to 288 wide.
Yep.
And the other, as you can see, it's also just 2 color. That's another important thing because, one, for memory and performance, and 2, because the more colors you're blending there, the more they might react to it in a way you don't want with the other colors, I think. So now let's load the other image, which is the foreground graphics. So the really tricky limitation of this method is wherever that back blit is happening, the mountain range in this case, there's a limit to which color indices we can use in the foreground graphics because you'll get sort of like a translucent effect when the background is drawn on top of specific color indices. We're using this one as the background color, so that's being drawn into to show the mountains through, but we don't want the mountains to show through anything else. So the colors we can use are these ones here. So we can't use this color, can't use this color, can't use this color, but all of these are the colors that we can use here. So this one, this one, this one, this one, and so on. But keep in mind, you only have to deal with this limitation in the region that the background graphics are going to be drawn. So that's another reason, aside from performance, that I did not have a really tall back layer, and we just use a background color for the sky, and then later on we use the rainbow command, which is the copper color changing trick on the Amiga, to add the illusion that that back graphic is full screen. So we have a nice gradation from darker to lighter sky toward the horizon, and then we add a lot more color to the mountain range, and then some reflected water and tree line colors. So we take this 2-color background graphic, and we, with the rainbow command, are able to make it look like a much more colorful background. Basically, you'll see from here up, I'll undo that, from there up, we don't use those other color indexes. Right. But the rest of the graphics from here down, where the mountain range is never drawn, here we can use all of the colors. And then if you're wondering why there's this weird background blue color down here as well, because I'm using the rainbow command to change colors for the background to make that more colorful, once we're down here and we're not displaying the background at all, we can use that same color index with the rainbow command to add more color. So you see I use it in the foreground grass, so I can have a different, more vibrant color of grass for the closer foreground. And then same thing here. It just allows me to add one more color for the dirt, just to add a bit more color to the screen. So that's the real big limitation to keep in mind if you're going to use this trick. And I'll go back into AMOS momentarily, and we can turn off the rainbow commands so you could see how it looks without any of the copper color changing trick hiding the fact that it's a 2-color background. And I'm making this actual AMOS project available for other people to sort of springboard off of. You do not have permission to reuse the graphics, but you can reuse and recycle and learn from the code. So if you keep the palette arranged in this similar fashion, then you'll know what to do. You can just copy what we're doing and just change the graphics. And you could, of course, also change the position and the size of the background graphics you're blitting. But if you keep using the same color indexes, you won't get hit with any surprises that you won't be able to figure out. So if you use this color here, I think it's this index that ends up getting used for the actual mountain range graphic itself. And
I believe that's true.
Yeah, and one unfortunate limitation in AMOS is the rainbow command per any one scan line only lets you change one color index. You can't have 2 rainbow commands going at the same time in the same location to change multiple color indexes, even though technically the Amiga is capable of changing a lot of colors per scan line. AMOS is not. So that's another limitation. You got to be really creative with how you're going to carefully change this one color index, however often you want, once per scan line, to create more color and detail in that background graphic. So let's go back into AMOS and check the code again to see how that works. All right, and I am going to search again, and what was it? F, so Windows or Amiga key F. There we go. We're going to find rainbow this time. And I think it's actually pretty much all the way down at the bottom. So now it's Amiga key N for the next one. The important rainbow that we need to turn off is 1. So there it is. Yep, at the very end. Okay. So now that I've turned that off, we'll still have the rainbow command changing, adding that dirt color and the other green color in the foreground graphics. Yep. But you can now see that it is indeed just 2 colors, that background, and it's purely clever use of the rainbow command to add the extra color to that background. And it is indeed that other index that was the one right after that color is the one that's going to be displayed as the second color of that back layer blit, if that makes sense.
Yeah.
So
I mean, from a technical or programmer's perspective,
yeah,
the blit is just changing the lowest bit in the binary number. So
yeah,
if your index is 2, when you blit into it, it's going to go up to the next
color index.
odd number. It's going to be 3
Okay.
in this case.
Right. Okay, so let's look at setBob again. setBob. I think it's something incredibly easy to remember and straightforward. I just want to double check. Yeah, it's literally setBob and then the number of the bob, and then how does that work again? I can't remember what the second number is after the comma, but then the third one is you're telling it which bit planes that you're going to be blitting to using like a hex value. So it's just %1 is the setting to get this background layer trick to work.
Yeah.
Do you remember what that second number is? It's been too long. I don't remember.
I'm looking it up right now.
Oh,
It's been a while
thanks.
too.
I appreciate that. In the meantime, while Mike is doing that, I'm going to quit out of this and go back to Windows to show you what gave me the idea for this in the first place that made me realize that it was probably possible for me to pull this trick off in AMOS was CodeTapper's awesome website. CodeTapper is an awesome longtime member of the Amiga community who has this great website with, there's a section called Sprite Tricks, which shows a lot of the most impressive classic Amiga games, and he reverse engineered them and shows you in very great detail exactly how extra layers of scrolling were achieved. And I knew Agony used actual dual playfield mode, but it had way more layers of scrolling than just 2. And so I looked at this analysis by CodeTapper, and in this he mentions that there's careful choice of what bit planes to draw to. And that reminded me that I thought, hey, I think there is a command in AMOS to be able to set which bit planes you draw. So that let me know that if I figure out the right indexes to use and the right bit planes to draw to, that I should be able to pull off the same exact effect. Of course, I got it working, but very poorly, and then Mike Ness here really helped optimize and get it performing well enough to actually work in a game engine. Oh, I should also mention, I will be making another video relatively soon showing using the same exact command setBob, but with different hex values and different color indices. You can actually get really nice, almost Super Nintendo translucent color style effects. There's actually several really useful variations of how that works. Just to give you a preview, I had made a tutorial and example AMOS file. If you go to BitBeamCannon.com and then Classic Systems Amiga, you'll find a section with some of the game projects we're working on, as well as some AMOS videos and the Rainbow Ripper tool. But so here it is. You can see here and here, there's 2 major translucent modes that you can use once you set up your palette carefully and understand which setBob command settings to use. But there's actually a third sort of mode that you can use that's also extremely useful, that depending on how your palette is set up, it will either lighten all of the colors, like it'll be a brightening effect, or darken, but not as extreme as half bright, which is obviously half as bright. You can do something where it just bumps up in a, for example, a 4-color range. You could see in this video here that I had set up the palette in ranges of 4 colors at a time, going from dark to light. What it's going to do is per 4-color range, it's going to bump it up to the next color. So it'll just slightly brighten the graphics wherever you draw a bob with that particular setBob command. So obviously, if you had set up your palette in reverse, where the color ranges were from light to dark, then it would slightly darken everything and create a shadowing effect, much more subtle than 64 half-bright mode.
Right.
So anyway, any luck yet, Mike? On that?
Yeah, I did find the meaning of that second argument there. It's 0 basically means that it's going to save the background and replace it when your bob moves. If
Yes. Okay.
If it's negative, or no, if it's positive, then it will just forget the background and not replace it when the bob moves away.
Okay, let's get back into AMOS. So you could see using that rainbow command to add the gradation to the sky, gradation to the water, and to change the color. So we have like a different color than the mountains for the tree line and just a gradient in the mountain. All of that combined, it really hides the fact that that's a 2-color image, and it also quite nicely hides the fact that that's not remotely a full screen background layer back there. Right. So a little goes a long way. Thank you. So keep that in mind. And then the trick for the rest of the parallax, down at the bottom, that's actually an entire other screen. That's a great thing about the Amiga and AMOS. They both let you have multiple screens going at once, and each screen can occupy a different vertical section of the overall screen. And by doing that, I'm actually I just put that other screen down there, which can have its own totally unique palette and can scroll at its own totally unique speed. So that's how I get that sort of row of extreme foreground bushes down there. And then I'm using the few sprites that are available to create that 16-color foreground tree. And then basically just when it goes off the screen on the left edge, I can repeat it again. So basically, it's possible. If I went with 3 color sprites, I might be able to get two of such trees on screen at a time, which might be worth it. But anyway, that's how all of this is working. Oh, and the top HUD is also a its own separate screen. And what's interesting is I am not using unique graphics and blitting the filled or empty health boxes. I'm actually hand changing color indices to darken it and redden it when it's empty, and to make it a nice brightly colored health point box in there. That's just another way to potentially save a tiny bit of memory and also not require update blitz into that screen. We're just switching screens in the AMOS command and then using the, I think it's called palette command, and then just picking the specific index and setting a new RGB value for those indexes to update the HUD based on the current health value. But anyway, that is it. That's how I got this to work. And like I said, check on the BitBeamCannon.com and then the, what was it, Classic Systems and then Amiga, and look for a screenshot of DaemonClaw, and I will add a download link for this actual AMOS project so you can learn from the code yourself. Obviously, I'm not talking to Mike. He helped make this prototype. He already has it and knows how it works already. Anyway, unless you have any final thoughts, Mike, that's pretty much it for this video.
No, I don't. You covered it well. Thank you.
Okay. Thank you very much, and thanks everyone for watching.
If you enjoy our content and want to keep up to date on our games, please leave a like and subscribe. Also, if you want to support our projects, consider becoming a patron. The link's in the description, and we'll see you soon.